So, levels of organization. Fuck. You're gonna have to edit
we can edit it out. Okay, go ahead. Get started. Levels of organization. Tell them about the levels of organization.
So, today, class, hello, welcome. This is Mr. Massey. We'll be learning about the levels of organization from smallest to largest.
Make sure they know it's like levels of organization in like the biosphere, the planet Earth.
Oh, so it's levels of organizations in the
biosphere.
Today we'll be learning about. You're not going to use this, are you?
Yeah, I am. Keep going.
Today we'll be learning about levels of organization in the biosphere, from smallest to largest.
All right, let's go. Go ahead.
All right. Is this the smallest or the biggest?
Yeah, because we're going from smallest to largest.
So smallest. Are we? We are.
Yeah.
Oh, we are. Okay.
Smallest to
so the smallest level of organization in the biosphere is the individual organism. This one is a zebra. What makes it the smallest?
What makes it the smallest? Well, it's the small. We could go smaller and be the cells, but an individual organism is the smallest.
So it's the biosphere. Look
the
at the
singular
big
unit of life. Yes.
All right. So the singular unit of life is the individual organism. Then we have the population, which is lots of the same type of organism.
Pretty close. So you have to include. There's two criteria to be a population, and that's that it's the same species living in the same area. So not only are these a bunch of zebras, but they're also living in the grassy field
So
together.
It's like I'm part of the same population as
right
people who live near me, but not as people in China.
Right. You do not belong to the population of China people. Oh. But you can look at populations of different sizes.
So just the Chinese.
Yeah, okay. Let's go with that.
And then bigger than population, we have the community. And the community is made up of all the different types of organisms that live in the same region.
Yes. Multiple populations does make a community. Correct.
Oh, sweet. All right. And then we have the ecosystem. And the ecosystem includes everything, both the living and the non-living things, like the clouds, the water, the temperature. There's a thermometer.
Climate, is included in our ecosystem.
So it's basically all the stuff that makes stuff happen.
All the stuff that makes stuff happen.
All right, I like that definition. And then zooming in.
You just to irradiate the point a little more. You can go to the next one. Yep.
And then the biome. And the biome, what is the biome includes?
So the biome is a similar ecosystem. So for example, right, you might be here in Rhode Island and you might see a forest with deciduous trees like maples and stuff. Then you might go to Connecticut and you might see the same type of forest. So these are similar ecosystems that you might find in several places around the world.
But they might not be all connected.
They might not be connected. For example, you can go to Nevada and see a desert, and then you can go to Africa and see a desert. They're on the opposite sides of the world, but they're both the same. They're both deserts,
like beaches.
Dry, not a beach. Yes, you see beaches all around the world.
There we go.
Yes,
Look at that. Beaches are biomes.
Beaches are biomes.
Begin with B. And then, we can skip this one?
You can skip this one, yep.
And then the biosphere, which is a planet, in this case, in most cases, the Earth, that includes all of the biomes that there are.
Did you see this Venn diagram with the smaller inside the larger?
Yes.
That's used to illustrate that each smaller circle is yet a part of the larger circle that it belongs to.
So you mean an individual organism is part of the biosphere?
Yeah, at the smallest level it is, because it's part of the biome, the ecosystem, so forth, so on.
That's kind of cool.
Makes it up.
Next slide.
Yeah, we're done with this one. So we're going to point out that we're looking specifically at interactions that happen within a community. So there's interactions that happen at every level, but the ones that we focus on in ecology happen at the community level.
I missed this part of the script. All right.
Yeah, you weren't paying attention.
So now go
ahead and click next. We're just going to load so we're going to talk about something called a niche.
Like an itch.
No, it's not like an itch at all. Do you know what a niche is?
Oh crap, you said this the other day in class too. I don't remember.
Okay, click next and we're going to tell you what a niche is.
Oh, it's the role a population plays in an ecosystem, including biotic and abiotic factors.
So what do I mean by the role that a population plays?
So say the bumblebee's niche is to pollinate flowers.
Right. So a lot of times we
really
use the analogy that it's an organism's job, but really it's just what the organism does. It includes where it lives, what it eats, and all those things in between.
It's the stuff it does.
It's the stuff it does.
Its role.
Yeah, it's role. That's why I use that. And I use my analogy. It's the job that a species does in an organism in order to survive.
In its ecosystem.
So what's it doing? How's it interacting with other things? That's its niche.
So the example here, would be a beaver's niche involves eating trees, building dams, backing up rivers, and changing the forest around it.
So these are all the things that a beaver does in its quest for survival out there in the
And it
ecosystem.
kind of helps the ecosystem function.
It could. It could very well. Probably does. Probably a very integral part of the ecosystem and its functioning. But we're going to talk about some things here.
You have a lot of blank slides.
Yeah. Oh, here's a beaver dam for reference, in case so the beavers built a dam. Come on, man, be serious. Beavers really do make these dams, and
Do they
really
really?
do back up the river. Yeah.
Why?
Because, well, actually, it's their home, Mr. Howard. They like to live there. But also because what happens is when they build the dam, it stops small critters like shrimp from getting through. So it's a way to kind of capture food. The dam not only provides a place for them to survive, but it provides them all this food source and and all these nutrients growing around their house. So it's actually a way. Beavers are kind of clever in that they cheat. By blocking the river, they get everything and anything that they want. Smart beavers.
Okay.
Yeah. So
sometimes when two species have overlapping niches, two things can happen.
Yeah.
And
Well-
I'm going to guess it's competition and collaboration.
No, that second one is not true. So the
Shit.
first one, so the thing that you need to know about niches is that really they can't overlap. If a niche overlaps, these species are going to be interacting some way. So the example I always give, if you and I lived in a forest and we both ate berries, well, we would obviously be fighting over the berries. So niches generally don't overlap in the wild. If there's an organism like a squirrel in the forest that eats acorns, no other organism in the forest is going to be eating acorns. Generally, niches do not overlap. Two organisms do not do the same thing. There are some rare exceptions to that, but they generally don't overlap. And that's because of this first point here called competition. Right. So when two organisms overlap, these populations are going to be competing for their resources.
So either one population loses and makes the other change their niche or go extinct. That's quite drastic.
Yeah, so if you think about it,
Oh.
well, let's start with that one. If you think about it, if we're both fighting over the berries, and we're both populations, we're not just an individual, you and I, but we're a population of, say, I'm the squirrel, you're the chipmunk. And I'm just better at getting...
I think the chipmunks are better.
Okay, let's say the chipmunks are better at getting acorns.
I like that.
So you're better at getting the acorns than I am. So what happens? Well, you get more acorns, you're healthier, you make more babies. Next year, there are more chipmunks than squirrels. And that continues to happen. And continues
Bye-bye
to happen.
squirrels.
Bye-bye squirrels. Eventually, the chipmunks take over because every year they win. They're just better, right?
We are.
What's going to happen is those squirrels are either going to die or they're going to have to leave that forest and find their own forest to live in.
Or find a different niche.
Find a different niche. They could change their niche, but generally organisms don't change their niche. 9 times out of 10, they're born that way. The exception is when populations change their niche so they can exist together. This is very rare. But some species of birds, for example, will live in the same tree, and what they'll do is they'll live in different parts of the tree. So you'll see with things like juniper trees that have those berries on them, like pine trees. You'll have like goldfinches living in the top. You'll have cardinals living in the middle. And that's because, well, the goldfinches say, okay, I'm going to eat the berries on the top. And the cardinals will say, well, I'll eat the berries in the middle. And now we're not fighting over the same berries.
Is that why they live in different places, Mr. Massey?
That's why they're living in different places, so they don't have to compete.
Okay.
So they do they divide the resource, or they divide the niche, so they don't have to compete.
Next.
Yeah, you can go next. We're about done with this.
Oh, example. Wolves prey on beavers. If mountain lions move into the area and also hunt beavers, the two species will be in competition because their niches overlap.
Right. So just like we said about the squirrels, they're going to be fighting over the food, and one of them is going to be better at getting the food, so one of them is going to have a greater chance of survival, greater chance
Like
at
5
reproducing.
seconds to realize with the different animals.
Yeah, those are different animals. One's a dog, one's a cat. Next.
Is this the second thing that can happen?
The second thing is called symbiosis. And symbiosis is just the word that scientists use for a close interaction between two organisms. So anytime organisms are interacting, we just the word use symbiosis. But it comes in 3 flavors or 3 categories, which we're going to talk about. So the first one is called parasitism. And this is when one organism is helped and the other is hurt. So you can think about an organism that gets some benefit from hurting other organisms.
So it's kind of like when someone copies off your test and you get caught and lose the points?
Yeah, kind of exactly like that, as long as they're not getting caught. Yeah, that's exactly like it. Now let's think of an organism in the wild that does this.
Tapeworm. Oh, hey, look it.
A tapeworm, because, it could live inside the gut of a beaver. It steals the nutrients. Have you ever seen, or dogs get them too, those worms that live inside your stomach, they're going ahead and they're stealing the nutrients. They're stealing the food from you. they're benefiting at your loss. Other examples might be, say, a tick that's sucking your blood, or a mosquito that's sucking your blood.
The tick is benefiting from living off of you,
and
you're dying.
And you're dying, or you're getting some sort of disease from the tick. So that's an example of parasitism or parasites.
Good email.
Oh, great. Next. Oh, what'd you do? You zoomed in. Come on. Go. Okay. Oh, and there's a picture of a growth swarm. Yep. So let's talk about the second type of symbiosis, and this is called mutualism. Go ahead and click it. Oh, sorry, commensalism. We weren't there yet. Commensalism is when one organism is helped and the other is unaffected. So in this case, one organism is getting a benefit and the other organism literally doesn't notice or care.
Is that like the bacteria that live in our guts?
So yeah, well, they help us at times digest food, so that might be different. I like to give the example of that beaver dam, right? So the beavers might have this dam that's blocking up all this algae in the water. Maybe some shrimp are coming around and eating that algae. Now, the beaver honestly doesn't care about the algae around its dam, but that's helping the shrimp out a little bit.
Okay.
You can think about maybe some other examples too. This happening, like I always give the example. It's on the worksheet, so I don't want to give it. But I'll give you an example of it. No, I won't.
You sure? I think you can come up with one if you take another 5 minutes.
I don't have 5 minutes. Let's just go to the next one. I don't want to give anything away that's coming up. There's a little
plankton.
Shrimp. He's eating the plankton. You can see that fuzzy stuff in the water. He's just having lunch.
I thought he had a beard.
The beaver doesn't care. Yeah, it's a bearded shrimp.
Do those exist?
Nope.
You should probably shut off those notifications.
Yeah, well, okay, now everyone just saw you shut off your notifications. Go ahead, last one.
Mutualism.
Which is when both organisms benefit. So this is like a you help me and I help you.
Isn't it with rhinoceroses in this?
Yeah, actually. I don't know if that's the example I have. Nope, it's not.
You're really into the beaver dams.
Yeah, well, beavers are one of my favorite of the mammal creatures. So beavers are helping the soil, which helps the trees. This is good for the beavers because they eat the trees. Good for the trees, good for the beavers.
But isn't it also bad because they're killing trees?
Well, you gotta lose a little, get a little. Another one is the one that you were talking about, the bird that lives around the rhinoceros.
Yeah, the bird.
Yes.
They eat the bugs or something,
it's called a flycatcher, yep. And so these flycatcher birds live around the rhinoceroses. So the rhinoceros is all stinky. They're attracting bugs. So what the flycatcher does is it hangs around the rhinoceros and helps eat the bugs. The flycatcher is getting its food from the bugs that are being attracted to the rhinoceros. Meanwhile, the rhinoceros is getting someone to help it avoid all the bugs. So it's kind of like a win-win, win-win, win-win. So good for you, good for me. Yeah, lots of wins. Now, Mr. Howard, let me ask you a question. Mm-hmm. There was one relationship that wasn't on this. So we had the example of someone getting hurt while someone's helped, someone's getting helped while the other person doesn't care, and both people being helped.
I know
which one's
when
missing.
Both people are being hurt.
And why is that not on here?
Because they'd both be dead. It's a stupid relationship.
It's a stupid relationship. So these relationships only occur if one organism is benefiting. Even if it's at the harm of another, that organism has to be benefiting. There's no relationship out there in the wild where both organisms get hurt, because why the hell would they participate in it? They just walk the other way. So that's an example that's why there's only 3 relationships: positive, negative, and I don't care, and positive. There's no negative. And I think that wraps up this lesson.
Oh, there's the beaver.
There's the beaver. I think that's all we have to learn about today, class. Education is valuable. That's just a quick review.
Well, that's it. It's over. Can we do it again?
No, you only do it once.
All right. I don't know how to close this.
Just the same way you started it.